In this video, I'd like to look at some extra examples for this complex numbers. And this was from section 3.4. So we'll start with some simplifying. We'll do like 3 examples. Number 1, the square root of negative 9. Number 2, the square root 3 square root negative 12. And number 3, let's go negative 2 square root of negative 45. So feel free to pause right here and try these on your own, or I will walk through them here in a few seconds. Okay, so let's try these on our own. Remember the negative just kind of pops out and becomes our I. So we have I times the square root of 9. Well, the square root of 9 is 3, and we'll put that out front. So it looks like I times 3, but I want to put that whole number that's on the outside of the radical out front. So we'll do 3i, like so. Okay, we can do the same thing for number 2. The negative pops out and becomes my I times the square root of 12. Now I got to break down 12. There's my pair of numbers. So I'm going to go 3i times 2 times root 3. My 2 pops out. My 3 goes back inside. Multiplying, and we get 6i root 3. 3 times 2 is 6. I stays I. Root 3 stays root 3. It's the same idea as number 2. We'll pop that I out first. Negative 2i times root 45. Now let's break down 45 off here to the side. 9 times 5 is 45. 3 and 3. So I get a 3 that pops out. So I'll have negative 2i times 3 times root 5. So the 3 popped out. The 5 goes back inside. Now we multiply all these together, and I get negative 6i root 5. Okay, so this is simplifying some radicals. Let's do some properties of I problems. Okay, so let's look at these. The best thing to do is to write it out as it's using the I to the 4th until we get to 16. So we'll say I to the 4th times I to the 4th times I to the 4th. So it's 4, 8, 12 times I to the 4th. Oh, that's 16. So this turns into 1 times 1 times 1 times 1. So I to the 16th equals 1. 1 times 1 times 1 times 1 is 1. So for I to the 13th, we'll do the same idea. We're going to I to the fourth, and then whatever we need to get to 13. So I to the fourth, that's 4 i's, times I to the fourth, now that's 8 i's, times I to the fourth, that's now 12 i's. So how many more i's do I need? I just need one more I to make it 13. 4 plus 4 is 8, plus 4 is 12, plus one more would be 13. So we get 1 times 1 times 1 times I equals I. So I to the 13th equals I. Do the same idea with I to the 10th. We're going to do those I to the fourths until we get close to the 10, and then we'll fill it out with whatever we need. So I to the fourth times I to the fourth, that's 8. So how many more do I need to get to 10? If I have 8, I will need 2 more. So I to the fourth is 1, times I to the fourth is 1, times I squared. Let's go back to my notes. I squared was -1. So times -1 would equal, well, 1 times 1 times -1 is -1. So I to the 10th equals -1. Let's do it one more time, using that I to the fourth trick to help us break it down. So I to the 7th has I to the fourth times, I need to get to 7, so we'll just need 3 more i's. So I to the fourth becomes 1 times, well, my I to the third, looking at my notes, is -1, or negative I should say. Sorry, misread that. So negative I. So 1 times negative I would be negative I. So I to the 7th equals negative I. So let's look at graphing complex numbers. So I drew my real, my imaginary plane. For the first one, I want you to build the complex number given the point. So if my point is over here, -2, 1, can you build the complex number? So the complex number is that a plus bi. And for what we're doing, we can almost think of it as x plus yi. It's kind of how we think of it on the complex plane. My x value, my x coordinate, plus my y times I. So the solution to this one would be, the complex number would be -2 plus 1i. Now will you please graph this one? Our x-axis is our real, our y-axis is our imaginary. So where would this point lie? Well, my x value is 2, and my y value is -3. So we're going to go 2, -3, and there's our complex point, like so. So we can build the complex number given a point, or we can plot the point given a complex number. So we'll need to be able to do both. The last thing I want to do is some examples when we're solving. So we're solving for x. So if we have 18 equals negative 2 and squared, x squared, we want to solve for x. So we go through our motions. We're going to isolate the square, then take the square root of both sides. Just kind of see how it unfolds. So I'll draw my line for organization. Right now I'm isolating the square, dividing both sides by negative 2. 18 divided by negative 2 is negative 9. Over here, those cancel out, and we have x squared. Now we'll take the square root of both sides. So when I take the square root, that's where my plus and my minus shows up. So we're going to use that symbol to keep it a little bit neater. I'll say plus or minus the square root of negative 9 is equal to x. Now I can say plus or minus I. I'm going to pop that negative out. Becomes I times the square root of 9 equals x. Now we have plus or minus I times 3 equals x. Square root of 9 is 3. Then I want to write it a little bit cleaner, so I'll say plus or minus 3i equals x. And there's my two solutions. I'm seeing two solutions right now. I have the positive 3i and I have the negative 3i. So this symbol lets me write both solutions at the same time. Okay, so let's try a different example. Say negative 25, 2. Negative 25 equals parentheses in minus 1, close parentheses, squared. Well, our square is already isolated, so we can go ahead and take the square root of both sides. So now I have the square root of negative 25 equals n minus 1. Square root got rid of the square. So let's take care of this square root of negative 25. Well, the negative pops out, becomes my I. I'm really just bringing this right-hand side down nonstop. Square root of 25 is 5, so I can have I times 5. Our plus or minus needs to show up. So we took the square root of both sides. That's when the plus or minus showed up. Then we popped out the negative, turned into our I. Now we're simplifying. Now we'll do our cleanup. And this has just been kind of coming down for the ride. Now I need to get n by itself. So I will add 1 to both sides. I cannot combine these because this represents my i's and this is my real number by itself. So this is a constant, so I'll have 1, positive 1, plus or minus 5i. And we're done with the problem. Okay, let's do one more. Let's say 2 times y plus 2 times x plus 2 squared plus 6 equals 0. So let's isolate the square. So we'll subtract 6 from both sides. So now I have 2 parentheses x plus 2 squared equals negative 6. We'll divide both sides by 2. And we get x plus 2 squared equals -3. So my square is isolated, and now it's time to take the square root of both sides. This is where my plus or minus will pop up. And I get rid of my square over here. So we'll simplify the square root. The only thing I can do is pop that negative out, turn it into an I. So I have equals plus or minus I root 3. Bringing down my x plus 2. I cannot simplify the square root of 3, so I'm ready to solve for x by subtracting 2 from both sides, and we get x equals -2 plus or minus I root 3. Okay, so there's some extra examples going from simplifying our square roots to using our properties of I to help us simplify these i's, to graphing some complex numbers, and then using all these skills to solve for x. So thank you very much for watching this video, and I hope you have a great rest of your day.